Hello, my name is Robert Ramdan, and our group consists of myself and Chad Mandy. I will be talking to you about the features of Gensim, the installation of Gensim, the auxiliary, summarization, and the topic coherence modules incorporated into Gensim. My group partner Chad Mandy will be going over the Gapora modules, the Gensim models, and the code demo. Onto our introduction slide. Gensim is a Python library that is used to automatically retrieve semantic topics from documents. Gensim is able to process the raw text referred to as plain text. There are algorithms in Gensim such as latent semantic analysis, latent Dirichlet allocation, and random projections, used to search through the semantic structure of documents by examining the statistical co-occurrence patterns of words within the corpus of training documents. The objectives behind the use of Gensim are easy-to-use interfaces and low API learning curves, memory independence that takes into account the size of the input corpus. The Gensim package involves the concept of corpus, vector, and model. On to our next slide. For the features of Gensim, we have the feature scalability, which gives Gensim the ability to process a large-scale corpora using the online trading algorithms. Next feature is going to be platform, which gives Gensim the ability to run on Windows, Linux, OS X, and any other platforms that support NumPy and Python. On to the next feature, which is going to be open source. The GNU LGPL license allows Gensim to be used for both personal and commercial use. The next feature of Gensim is implementation, which gives Gensim highly optimized mat routines in its algorithms. Some of the Gensim algorithms also allow for faster processing and retrieval on the machine clusters. Next feature of Gensim are the converters and the I/O, which allows Gensim for popular data formats to be used as inputs, outputs, and to be converted from one to another. Next feature is to be matching queries. Gensim has code that allows for fast retrieval of similar documents. For the last feature for support, Gensim is backed by a community through which it is supported and maintained. Onto our next slide, which is going to be installing Gensim. To install Gensim, you need Python, NumPy, and SciPy. You can install Gensim using the following commands on the slide. Python version needs to be greater than or equal to 2.6. NumPy version needs to be greater than or equal to 1.3. And SciPy version needs to be greater than or equal to 0.7. Onto our next slide, which is Gensim auxiliary modules. We will begin with Gensim parsing. We have the Porter stemming algorithm, which is a stemming algorithm that allows an array B to be a buffer which is holding a word to be stemmed. Letters are placed from position 0 to k in array B. The methods for the Porter stemming algorithms are stem documents, and stem sentence. The preprocessing for the Gensim parsing module contains functions to preprocess raw text. The method for preprocessing is stem, which returns the lowercase, the stem version of the string text. Onto Gensim scripts. For scripts, we have the make wiki corpus. The make wiki corpus will convert articles from the Wikipedia dump to vectors. The input will be a BZ2 compressed dump of Wikipedia articles in a XML format. Vocabulary size controls how many of the recurring words to keep. For Word2Vec standalone, for that script, it is used to train the Word2Vec on text file corpus and will train a neural embedding model on the text file corpus. On to Gensim similarities. The similarity class splits the index into smaller indexes. The class allows us to build an index of these set of given documents. We can then build efficient queries to compare our query document to each document in the indexes to see how similar they are. The result of the query is a vector of numbers which is large as the size of the initial set of documents. On to our next slide, which is the Gensim summarization modules. The text cleaner module for Gensim has a function called clean text by sentences, which tokenizes the text into sentences, then applies filters lemmatizing them, and then it returns a syntactic unit list. Another function in the text cleaner module, which is clean text by word, which tokenizes the text into words, then applying filters and lemmatizing them. It will return a dictionary of words to a syntactic unit. Next, on to BM25, which is a summarization module, which is a ranking function that summarizes the document that gets the scores from the corpus. Next, on to weighted page rank, which is an algorithm for the summarization module that helps build graphs that show the probability and weights for the commands. Onto keywords. The keyword module for the text rank summarization algorithms are filters for nouns and adjectives. On to our next slide, which is the Gensim topic coherence module. For aggregation section of one of the topic coherence modules, the aggregation module contains functions to perform aggregation on a list of values from the confirmation measure. The command arithmetic mean performs the arithmetic mean aggregation on the output obtained from the confirmation measure module. For the probability estimation module, it has a function perform segmentation on probability estimation. The function p-boolean documents performs the document probability estimation, which estimates the probability of single words as a number of documents, which is calculated by the word frequency by the total amount of documents. The function b-boolean sliding window performs the Boolean sliding window estimation, which determines the word frequency using a sliding window. The window scans over the documents with one word token per step, and each step has a new virtual document by copying the content of the window. On to the segmentation module, which has the functions s11, s1 pre, s1 set to perform segmentation on a list of topics that are obtained from an algorithm such as LDA, which is the latent Dirichlet allocation.
Hi, my name is Chad Manny, and I'm going to go over the Gensim Corpora modules, the Gensim model modules, and finally a code demo to show how it works. So Gensim offers many different methods of representing Corpora and provides the ability to handle some of the more popular formats used by other packages and programs. The CSV module allows a Corpora to be loaded from a CSV, and Gensim will then guess the delimiter and headers based on the content in the CSV file. The dictionary can be used to load documents and display the bag of words representation of it. By default, infrequent words are pruned to reduce the memory footprint. There's also the ability to filter out extremes, the most infrequent words, and filter tokens on demand. The index corpus allows random access, resulting in O of 1 lookup time for accessing documents. The low corpus is used to support the Gibbs LDA++ list of words format of Corpora, while the mallet corpus is used to support the mallet list of words format. The corpus supports the matrix market format, while the SVM Lite corpus supports the SVM Lite format. Gensim also provides a sharded corpus to bring a balance between speed and memory of the model by splitting the corpus into a series of shards, which are chunks of data containing the given number of data points. The shards can be resized by reserializing the entire corpus if necessary. When using the corpus, each shard is loaded one at a time from the disk to reduce the amount of RAM used in training. One thing to note is that this dataset is read-only and is intended for use in situations where it is necessary to train a model on extremely large matrices. Text corpus is Gensim's way of letting the user use their own defined format of corpora stored on a disk by overriding a single method, the getText method, also providing a method to get the length of the corpora if it's used anywhere else. The user can choose to do all stemming, preprocessing, and tokenizing here if necessary. The text corpus can be used as an input to all Gensim models and can be serialized in any format. This allows users to not have to worry about tweaking their corpora, but instead they can just need to change the code to be able to handle their specific format. I'm going to go over a brief demo of how to use the text corpus to go over our homework 1. Finally, there's the wiki corpus, which can take a Wikipedia database dump and turn it into a corpora for processing for something such as a knowledge engine. Gensim provides many different models to handle various forms of data representation. And in Gensim, the models are just an abstraction referring to the transformation of one document representation to another. The LDA model is a latent Dirichlet allocation that allows model estimation from a training corpus and inference of topic distribution. If you wish to take advantage of multi-core CPUs, you can use LDA multi-core for parallelization. This model runs in constant memory, meaning it can process corpora larger than the RAM could handle normally. The LSI model is a latent semantic analysis or latent semantic indexing module that also uses constant memory and can be parallelized with a distributed flag as opposed to a separate model. The TF-IDF model can compute the TF-IDF matrix for a given corpus with the option to normalize the input. The norm model can compute the explicit normalization of vectors in a given corpus. Doc2Vec provides deep learning with distributed memory and a bag of words models. It can compute the cosine similarity, score a sequence of sentences, check if something doesn't match, check what's most similar, handle tagged documents, and even supports online training. So you can save a model and reload it at one time later in the future, and then just continuously train more documents on it. Word2Vec is very similar to the Doc2Vec model. It provides deep learning by using skipgram and SIBO models. But instead of working on documents, it works on words. These deep learning methods allow us to use unannotated plain text and then use the output vectors in an algebraic fashion to compute similarities. I'm also going to do a demo of this using the text corpus as an input to it. In addition to models, Gensim also contains Python wrappers around some of the more popular algorithms, such as var embed, word rank, and fast text. So for the text demo, I'm going to show you how to use a text corpus to create your own corpus, and then how to print the TF-IDF, do some similarity queries, and then play around with Word2Vec for a little bit. So the first thing we need to do is import some functions from Gensim, namely utils, corpora, models, and similarities. After that, what we should do is we should go ahead and create our class. This class is based off of the text corpus. It has a stop list, which contains a few words to parse out and pre-process. The get text method is overridden to stream from our document and handle the format it's in. The document we're going to be using is news article from homework 1. Then I overrode the length, and then that gives us the text corpus. The next thing we're going to do is go ahead and load up our article, and then feed the article into our class we just created, and now we have a homework corpus. From there, I can go ahead and create a TF-IDF model using the corpus and the dictionary from the corpus. And then this gives us 17 documents with 339 non-zero elements. Then I'm going to create a similarities index to be used later on by passing in the TF-IDF that I just created with homework as a feature inside of it. And then what I'm going to do next is show a bag of words model. And by doing that, I'm going to get every single text inside of the news article, and then feed that directly into the doc2 bag of words method of the dictionary that was created. And we can print it out and see our bag of words model. Now to see the TF-IDF for all of these, we just pass in the bag of words that we just created directly into the TF-IDF. And then here's our TF-IDF for all of them. Now I'm going to create a query to look inside against the news article. I'm looking for financial stability in banks. So we create a query, split the strings, so we have a list of the strings, and then we pass it into the doc2bo, and that gives us our bag of words output, which will contain 3 words because N is one of the stop words that was removed. And this is the TF-IDF that was extracted from our query. and then we can feed that directly into our index we created earlier, and this will go ahead and give us the similarity TF-IDF. So the next thing I'm going to do is create a Word2Vec model. I'm passing in a list of all of the words inside the article, and then I'm going to set minimum count to 1. As we don't have a very large data set, minimum count is not going to, it needs to be as low as possible so we keep as many words as possible. Now, it's not going to give us a very accurate model, but it's enough to prove the concept. So this creates our model, and then I'm going to run a similarity query in the form of French is the European as pay is to negotiated. It doesn't make perfect sense, but it makes some sense in the context given the words that we trained this on. And then I'm going to use the doesn't match function, and between debt, pay, and profit, the Word2Vec model thinks that debt doesn't match. And then for a quick similarity, I'm going to use the similarity between profit and pay, and it says that it's about 5% similar. Now keep in mind, if you had a much bigger corpus of 3 billion words instead of 300 words, this would make a lot more sense. And that is the quick code demo.